Good morning to all. I am Dolphin, working as an assistant professor in CSE department at Emmanuel Arthur JJ College of Engineering. I am handling one of the subject cloud computing, subject code CCS335. Let me see about the Unit 1 topics. Unit 1 title Cloud Architecture, Models and Infrastructure. Topics are cloud architecture, system models for distributed and cloud computing, NIST, cloud computing reference architecture, cloud deployment models, cloud service model, cloud infrastructure, architectural design of compute and storage clouds, design challenges. These are the topics covered in Unit 1. Now we discuss about the cloud architecture system models for distributed and cloud computing. Here, what is a cloud architecture? And it is a distributes the file system and spread over the multiple hard disk and machines. Here, the data is never stored in one place, and in case one unit fails, the other will be take over automatically. And the design will must provide automated delivery of cloud services along with the automated management. It will support latest web standards like Web 2.0 or higher. It must support very large scale HPC infrastructure also in both physical and virtual machines. In user disk space, it is allocated on the distributed file system, while another important component is an algorithm for resource allocations. The architecture of cloud must be loosely coupled. The cloud computing is a strong distributed environment and it heavily depends upon strong algorithms. Inside the cloud architecture, next we discuss about the layer design. Here, the layer architecture of the cloud is composed of three basic layers that is called infrastructure, platform, and application. These are the three layers of layered architecture. The three layers of architectures are implemented with virtualization and standardization of cloud provided hardware and software resources. Architectural design facilities are public, private, and hybrid also. It is conveyed to the users through network support over the internet and the intranet. It's the first layer to be deployed before platform and application to get infrastructure as a services and run to other layers. It contains a two parts, front end and back end. If front end means client uses the front end, it contains a client side interface and application. Both of these components are important to access the cloud computing platform. The front end includes web server that is Chrome, Firefox, Opera, etc. The client and mobile devices also. If the back end means it helps to manage all the resources needed to provide cloud computing services. The cloud architecture parts include as security mechanism, large amount of data storage servers, virtual machines, traffic control mechanism, etc. System models for distributed and cloud computing. Here, the distributed and cloud computing systems are built over a large number of autonomous computer nodes. The node machines are interconnected by storage area network, local area network, and wide area network in a hierarchical manner. These three networks are interconnected by a hierarchical manner. Next, the LAN switches can easily connect hundreds of machines as a working cluster. The WAN can connect many local clusters to form a very large cluster of clusters. Here, the massive systems are classified into four groups. The first one is clusters of cooperative computers. Here, the computing clusters consist of a interconnected stand-alone computers that work cooperatively as a single integrated computing resource. Inside that cluster architecture, The architecture is a typical server cluster that is built around a low latency, high bandwidth, and interconnection network. This network can be as a simple as a storage area network or a local area network. Next, we discuss about SSI. SSI means single system image. Here, the cluster design is as cluster OS or system middleware that can support to SSI at a various levels. Here, we including a sharing of your CPUs, memory, and I/O across all cluster nodes. But the SSI makes the cluster appear like a single machine to the user. Next, here we using hardware, software, and middleware support. Next one is that is it explores massive parallelism that is commonly known as MPP. Next, it is most cluster run under the Linux OS. For example, distributed memory has multiple images. User may want all distributed memory to be shared by all servers that will form by forming distributed shared memory, that is DSM. Next, we discuss about the major cluster design issues, that is OS or middleware extensions are developed at the user space. Next, it achieve SSI at selected functional levels. Without the middleware, cluster node cannot work together and achieve cooperative computing. The software environments and application on the must rely on the middleware to achieve high performance. Next, we discuss about grid computing infrastructures. The web service such as HTTP, Hypertext Transfer Protocol, it enables the remote access of remote web pages. Here, the grid computing is envisaged to allow close interaction among applications running on in distant computers simultaneously. Next one is computational grids. Here, the grid is structured across LAN, WAN, or Internet. These are the backbone networks at the national or global or regional. Here, the organization present grids as a integrated computing resources, but it viewed as a virtual platform. It will support the virtual organizations. But the computer used in a grid, it is primarily workstation, servers, clusters, and supercomputers also. But the grid families, next is the grid families. Here, the grid technology demand a new distributed computing models, software, middleware support, network protocols, and hardware infrastructure. Next is peer-to-peer network families. Here it will offers a distributed model of networked system, but the network is client-oriented instead of server-oriented. It introduced a physical level and overlay networks at the logical level. Next, peer-to-peer systems. That is autonomously to join or leave the system freely. All client machines will be autonomously to join or leave the system freely. It contains two abstraction levels. Initially, the peers are totally unrelated. That each peer machine joins or leaves the peer-to machine network voluntarily. Only the participating peers from the form the physical network at any time. Next is overlay networks. Here, the data items or files are distributed in participating peers. The based on the communication or file sharing, the peer ID form an overlay network at the logical level. Then the overlay is a virtual network formed by mapping each physical machine with its ID through a virtual mapping. Here, two types of overlay network. One is unstructured and another one is structured. Here, structured means it follows certain connectivity topology and rules for inserting and removing the nodes from the overlay graph. But the unstructured overlay network is a random graph. It characteristic by a random graph. Next, peer-to-peer application families. It is a file sharing of digital content, for example, music, videos, etc., on the peer-to-peer network. But it includes many popular peer-to-peer networks such as Napster, BitTorrent, among others also. Collaboration of peer-to-peer networks include a MSN or Skype, chatting, instant messaging, and collaborative design, among others. Next is the peer-to-peer computing challenges. Here, it facing the three types of heterogeneity problems in hardware, software, and network requirements. Here, too many hardware models and structure to select this firm. Incompatibility exists between software and the operating system, and its connections and the protocols make it too complex to apply in the real applications. But the internet clouds is the idea to move the desktop computing, the service oriented platform using the service clusters in huge database at data centers. But the cost of the cloud computing leverages is low, and simplicity. The benefit, it is benefit to both users and the providers. Thank you all for listening the presentation.